So this time I'm looking at the second subgroup analysis and exploration of heterogeneity, where we have the dataset divided into ELISA-based versus non-ELISA-based estimates of prevalence. So again, I'm just going to do a little bit of moving things around. I'm going to use the risk ratio again. By the way, what you'll notice is when I change from the odds ratio to the risk ratio, you'll notice that these estimates are all going to move in towards the null because the risk ratio is always closer to the null than the odds ratio. So let's see if I'm right if I do that. So this one will go from 10, should be closer to 1, and this one should be closer to 1. And yeah, marginal, just a tiny bit. But that's one thing to remember, that the odds ratio is always further from the null than the risk ratio. So again, I'm going to change to the random effects, and I'm going to have a look at the scale that I have. I don't like it going to 100. I'm going to change this. When I look at most of the numbers, apart from a few real outliers, they're mostly less than 5. So I'm going to go in here to Properties. I'm going to go to this End tab called Graph, and I'm going to change it to 5. Now last time, remember, I also changed these labels. And what we had was that if it was on the left-hand side, that meant it was higher in buffalo. And if it was on the right-hand side, it's higher in cattle. So let's just verify that. So here we have an estimate where the number of animals that were tested positive is roughly the same, but we have fewer total animals in cattle. That means the prevalence must be higher in cattle. So it's 1.26, and scrolling down, yes, that's what it says, higher in cattle. So now that I've got things arranged the way I like, I'm going to click on this forest plot graph, bring it up so I can have a look. So as with last time, I'm going to look in the first subgroup. There's a couple of things that I see here. Again, there's a spattering of studies. There's a very big study, but its confidence interval is incredibly wide because we have a 0 here, and the same with this Calvin study. So really, we know very little about those estimates, and they're not contributing very much weight to this parameter estimate, this summary effect measure. If I remove them, I know that this 1.12 is not going to change very much, and I'm sure if I remove them, I will decrease this heterogeneity, but I'm not even sure I need to. You know, this is a p-value of 0.1, this is an I-squared of 39, and I still have these two studies in here. So part of me says, you know, I know these are big estimates, but they're not being really influential. And overall, I would be inclined to agree that to conclude, having not read the papers, by the way, that this suggests that I can create this summary, I can interpret the summary effect measure, and here it is. And I didn't do this in the last one, but here's the test of overall effect. So this is the Z, and what this is asking is, the null hypothesis is that this total weighted average effect is equal to 1, the null. And the p-value is 0.545, which says, you know, there's no evidence to reject the null. So overall, when you take all these estimates, the estimate that you get is that there is no difference in the prevalence ratio of cattle versus buffalo. So I'm going to close it now and do my little bit of a sensitivity analysis. I'm going to remove this Calvin study just so I can see what's going on. Did I remove the right one? Yes. And then look at my figure again. And you can see here that those two studies were driving almost all of the variance. It didn't change the summary effect measure at all, but they were really explaining the variance. And so then you think, well, should I really remove them? But we know those estimates with such uncertainty that it's hard to think that they should be really influential. So as I said, I'd probably reach a conclusion about those and say that based on the ELISA, what we're seeing is no real difference in the seroprevalence of cattle versus buffalo.